Shapes in hyperbolic geometry are harder to represent than they are in Euclidean geometry, mainly because we're just all used to Euclidean geometry and representing points that way, or shapes that way. So in this video we're going to go over Poincare's upper half-plane model. For hyperbolic geometry. And this will be video 2.040. So let's do this first part of it in green. We'll say points. So a set of points we'll call it P, is equal to, and it's represented this way. It's represented x comma y such that y is greater than 0. And this is why we call it an upper half-plane model. So let's see. For this, we'll have this dotted line here, and points will say y equals 0, this will be y equals plus, and this will be y equals minus. So a set of points has to be anywhere, or these should all be x's, not y's. So a set of points is anywhere that it can be anywhere as long as y is greater than 0. This will be y equals 0, so we cannot have a point where y equals 0. Y equals 0 is not a point. Well, it would be x equal n, y equals 0 is not a point. We can also represent lines. Let's border this off. These lines. These consist of two types of sets of the form. Let's do this one in turquoise. So they can be of this form right here, where it's x comma y, such that those are x and y here have to be points. So we'll just say element of P, such that x equals a, and that's for some constant a. And this is represented by, once again, a dotted line for the y equals 0 axis. And this kind of point would be, or this kind of line, it does not touch the y equals 0 axis, so we draw that open circle there, but it gets as close as possible. And we'll have some kind of a sub n right here. Let's do a sub n. And they can also be of any other form, or of the form, let's do this one in, let's go with orange. So it can be of the form x comma y, where that's an element of our plane, such that x minus c, let's actually do that on a separate line. it gets kind of long, and I don't want to have this separated. So that'll be of the form x comma y, such that those are elements of our point, such that x minus c squared plus y squared equals r squared for some constant c. And this is of the form where we would have a point here, and it would create an arc. In that arc, although it's not how I've drawn it, because my art will never be perfect, that is a perfect semicircle. Just pretend that's a perfect semicircle there, minus 1 point, or 2 points, however you want to call it. So that's how we can represent things in the Poincare upper half plane model. We won't be representing points like this very much. We're mainly going to deal with these lines that are an arc shape. We will occasionally have these lines that are just a straight up thing, where the x is constant.